All right, everyone, we are back and we are on our Pset 4 solution video. So, fill out the sections of the phase diagram. So let's go ahead. This is a gamma phase, so this is gamma plus alpha here. This will be alpha plus liquid in that little sliver right there. Liquid plus molybdenum, molybdenum plus sigma, molybdenum plus, mu. Yeah, mu. Forgot my my little lambda plus mu, gamma plus lambda, gamma plus mu. What is it? This will be. Oh, excuse me. Excuse me. That's not going to be. That's going to be alpha. All those are alphas, but you get the picture. Alpha plus R right here. Liquid plus R right here. Liquid plus sigma right there in that section. So fill out the phase diagram. Draw those isotherms, touch the phases. Integrate congruent melting points and invariant points. So congruent melting point here. We also have a congruent melting point right here. All right. So this is liquid plus one phase into... So let's actually start from here to here. This is probably a little eutectic point right here. But if you miss it, it's okay. This is a solid plus another solid to a new solid, so that's a peritectoid right here. This is a solid to a two-phase solid here, so that's a eutectoid. This is a solid plus another solid to a single-phase solid, so that's another peritectoid. This is a liquid plus a solid to a new solid, so that's a peritectic. This is also a peritectic right here. Those are just conventions. Solid to another two-phase solid, that's a eutectoid right here. And that's pretty much it. Great. Consider the composition at 40% molybdenum and then at 800. So basically, let's just put it right in the middle here. So at 800. So what are the phases here? So the phases are mu and lambda. So this is phase one. We're in a two-phase region here. What is the composition and fraction of the material? So the composition in the mu is going to be equal to, we just remember, run to the right. So let's just call that 41. The composition in the lambda phase is going to be what? 31, 32, 33. The fraction that's in the mu, remember, is going to be the total length of that line. So 41 minus 33. And remember, we run opposite. So it will actually be, for at 40%, it'll be 40 minus 33. Makes sense because we're really, really close to mu. It should be the larger phase. The fraction that's in the lambda phase should be the opposite, which is going to be equal to... So for the lambda, we still have our lever, minus 33. But now, again, we run opposite. So it's actually going to be, we're going to run towards the mu. So it's going to be 41 minus 40. Makes sense because we're closer to mu. So we should have that solution. And finally... Okay, composition and fraction is done. Right, the chemical potentials. Well, we know if we're in a two-phase region, chemical potential of both phases must be equal to one another. There you go. What are the degrees of freedom? Let's go ahead and do that. So degrees of freedom plus phases equals C plus 1. Compositions or components, 2. Iron, molybdenum, so that's 2. Phases in this region is also 2, so degrees of freedom is 1. Perfect. All right, draw the free energy curves for this phase diagram at 1700 C. Okay, here we go. So let's go ahead and draw a line here, 1700 C. Oh, I was nice on this one. So let's go ahead. I'm going to change colors. I'm going to go to black. So we're going to go here and here. And remember, every time we cross a line here, we're going to draw these little dashed lines here. So from here to here, we are pure phase liquid. Then from here to here, we are liquid plus, and I'm just going to call this solid 1, just for my notation's sake. And then after that, we are just solid 1. So we know when we're in a two-phase region, we need to have, I wonder if I can do this. Let's just do this here. We need a common tangent. And that common tangent means that the chemical potentials are equal and also that the slopes are equal. So we're lowest phase here. We're going to touch and then disappear. Here we have to be higher because lowest free energy wins. We're in a single phase region. Here we need to touch here. And there we go. We can check. Single phase region, lowest free energy wins. Two phase region, common tangent. So points are touching here and here. And then final single phase region, lowest free energy wins. We're good to go. Great. That's the first problem done. So let's go to the next problem. Fill out the phases. So same idea. Here will be FCC in liquid, liquid plus BCC, MONI plus BCC, this plus this, this plus this. You get the picture. But again, I need you to write that all out. But we've done it enough. You kind of get the idea. Congruent melting point here, and that is it. Let's start to look at some invariant points. So this is solid plus another solid to new solid, so that's a peritectoid. This is a solid two-phase solid region to a single-phase solid region, so that's another peritectoid right here. This is a eutectic, liquid to two-phase solid region. We are liquid plus solid to a new solid. That's a peritectic. I think that's it for invariant points. That is true. 0.3 mole fraction of, hopefully Ni, but you can answer it either way. 0.3 at 2,000. So 0.3 at 2,000. This is a good one. What are the phases? Liquid. What's the composition? Composition is 0.3. Fraction is 100% liquid. 100%. Chemical potential, we're pure. The chemical potential is the chemical potential of, liquid. There's no two different phases. Great. Free energy curves at 1200. Okay, here we go. This one's a little bit more challenging, but we can do it. So actually, I'm going to kind of draw it out here. So let's go ahead and we'll draw it right up here. So remember, every time we see a dash, we just draw it up. Then we draw it up here. Another dash here. Just do to exaggerate it a bit. And then finally, and we're just going to assume that it's just all this last phase. So let's go ahead and see what we've got cooking here. So we have solid 1. Then we have solid 1 plus solid 2. Actually, I should do solid 1, and then I'm going to say that this is solid 2. Then we're pure solid 2 for a while, and then we're solid 2 plus, and I'm just going to name this last one. We're going to do this solid 3. So let's go ahead and sketch it out. So there's a common tangent here, and then a common tangent. Let's just put it up here. It doesn't matter. Here. So let's go ahead. I'm solid 1, lowest touch, and I'm gone. This is a tricky one. So what was solid 2 blue? Yeah. So I'm solid 2, so I need to touch here. Now I'm going to hang out here for a while. It's just not that bad. And I'm going to touch right there. I'm touching in parallel to that line. And then solid 3, I'm going to hang out here, and then I'm going to touch all the way here. And there we go. That's it. Problem set 4 in the books. Good luck on the exam. We'll see you for problem set 5. Thanks. Bye.